Okay, let's unpack this. We are diving into a phenomenon that it fundamentally breaks the rules of reality as we understand them. I want you to picture this scenario. It's a classic eyewitness account, documented for centuries. You're inside during a violent thunderstorm,
Mm.
and suddenly, just hovering there, a few feet above your carpet, is a perfect, luminous orb,
Glowing.
glowing with this soft, steady intensity. It's maybe the size of a soccer ball. And it's moving slowly, very deliberately across the room.
And then comes the impossible part.
Exactly. It gets to a closed window or even a solid brick wall, and instead of stopping or, burning a hole through it, it just silently passes right through.
That single image really defines our deep dive today. We are exploring ball lightning, or, as some historical sources from the Middle East called it, Karat al-Barq, the sphere of lightning.
Wow.
Yeah. And it's a natural electrical phenomenon that is so rare and so contradictory to modern physics that its existence basically forces us to admit we might be wrong about some very basic things.
About matter and energy itself.
Pretty much.
So our mission today is to give you a real shortcut to understanding this. We're going to synthesize the few known facts. We're going to dissect the scientific theories trying to explain it.
And most importantly,
And most importantly, we have to confront how it seemingly violates all the laws of matter by just moving right through solid objects.
and let's just start with the biggest challenge right up front. Ball lightning is an acknowledged real thing. Scientists agree it exists. But despite being seen for hundreds of years and even caught on video now and then,
Right.
they openly admit they have no complete working theory to explain it. It's just this electrical riddle that refuses to be solved.
Okay, so let's start with the basics then. What does this thing actually look like? Because the descriptions must be pretty consistent if we're treating it as a real phenomenon.
They are, and that consistency is what gives it so much credibility. Witnesses almost always describe it as a distinctly luminous spherical ball.
Hmm.
So the name is, very accurate.
And size-wise, are we talking about a marble or...
It varies, actually. Reports range from as small as, say, 10 centimeters, like a grapefruit, all the way up to about 40 centimeters. So, yeah, closer to a basketball on the high end.
And the color? Is it always that classic lightning white?
Not always. And that's actually a key clue for scientists. Most reports are bright white or yellow, but we also have accounts of red, orange, and even blue spheres.
Which suggests what? Different temperatures.
Exactly. Variable temperatures or maybe different chemical compositions in the air.
And unlike regular lightning, this thing,
Yeah.
it lingers, right? It doesn't just flash and disappear.
Precisely. Its movement is almost always described as slow. Floating, drifting, often just a bit above the ground. It can last for several seconds, sometimes even a full minute, which is an eternity for an electrical discharge.
And then it's just gone.
Just gone. Disappears as suddenly as it appeared, leaving people completely baffled.
That visibility makes its rarity even more frustrating for researchers. It's right there, but we can't grab it and study it.
We can't. And that's why scientists call it possibly the rarest electrical phenomenon on Earth. We have no controlled data, just these thousands of anecdotal reports.
So that rarity really just compounds the problem.
It does. I mean, it leaves us with three fundamental unanswered questions. And there is absolutely zero scientific consensus on any of them. It's a physicist's nightmare.
Okay, let's lay them out. What are the three big roadblocks?
First, no one knows how it appears. The formation mechanism is a total mystery. Second, no one knows how it disappears, what makes it stop. And as we'll get into, that can be pretty dramatic.
And the third?
And third, the biggest mystery of all. No one has a clue how it passes through solid walls, glass, even metal, without leaving a single trace.
That third point is, it's the whole ball game, isn't it? That's what makes this sound like science fiction. We're talking about something that challenges our most basic ideas about how matter works.
It absolutely does. When you dig into the witness accounts, this is where it just goes completely off the rails of known physics. I mean, forget the light for a second. We're talking about an object or an energy structure that seems to just ignore that matter is solid.
So give us the examples. What kinds of things have these balls reportedly just passed through?
Well, we've got accounts of it going through thin things like window panes, which is weird enough. But then there are reports of it passing through thick, solid brick walls, wooden doors,
In metal, you said.
and even conductive metal objects. It's almost like the ball lightning exists on a different plane of reality than the house it's in.
Okay, let's just stop there and really focus on the physics of that.
Yeah.
If this thing is some kind of plasma, it has to be incredibly hot to be that bright, right?
It would have to be, yes.
So if a superheated object hits a wall. Basic thermodynamics says it should, at a minimum, heat the wall. Probably it should burn it, melt it, something. Why no scorch marks?
And that is the critical failing point for almost every theory. The reports are adamant. It passes through these things without burning them, without leaving any physical damage, and, get this, without even making a sound?
No sound of impact.
None. It doesn't seem to interact physically or thermally with the object it's penetrating. It's just on one side and then it's on the other.
That suggests it's what? Not really made of matter as we define it. I mean, if it doesn't transfer heat, what is it?
It raises some really profound questions. Is the ball itself not subject to the basic rules that say two objects can't be in the same place at the same time? I mean, it moves through solid objects, but we can still see it.
Yeah.
It defies any simple category we have.
Faced with this impossibility, the scientific community hasn't just given up. They must have some robust theories about what it's made of, even if those theories can't explain the wall thing.
Oh, absolutely. There have been many attempts to explain its substance, its stability, how it holds together for so long.
Okay, let's unpack the big one. I always hear about the plasma theory. How's that supposed to work?
So the plasma theory is the most intuitive one. The idea is that ball lightning is a ball of high-temperature, ionized gas plasma. Think of it like a tiny piece of a star, but somehow stable in our atmosphere.
Okay, but what's holding it together? It should just dissipate instantly.
Well, the theory is that it's contained by a powerful self-generated magnetic field.
A sort of magnetic bottle.
Exactly, a magnetic bottle. This field is supposedly generated by the electrical currents inside the plasma, and it traps all the hot particles, holding it in that perfect sphere shape. It explains the light and the stability pretty well.
Okay, that makes some sense.
Yeah.
But what about the other ideas? I saw a mention of a microwave theory.
Right. The second hypothesis is a bit different. It suggests the ball is actually being fueled by energy from the outside. The idea is that during a big storm, the atmosphere can act like a waveguide for powerful microwave radiation.
Okay.
And the ball lightning is like a little resonant bubble of ionized air that's perfectly tuned to absorb that microwave energy from the environment.
So it's like a tiny, self-sustaining microwave oven cooking itself with energy that's already in the air around it.
You got it. That would explain why it mainly happens during storms, and it could also explain why it doesn't seem to be as catastrophically hot as a piece of a star. The energy is being fed in, not just contained.
And the third one, I read something about silicon.
Yes, that's the most modern and in some ways most compelling theory. It's the silicon vapor model. It suggests that when lightning hits the ground, specifically soil that's rich in silicon.
Which is most soil.
Right. The intense heat vaporizes the silicon into these tiny nanoparticles. The ball lightning in this model is actually a floating, burning cloud of these nanoparticles reacting with oxygen.
So it's not plasma, it's more like a really exotic fire, a burning dust cloud.
Essentially, yes, a kind of weird contained combustion. This theory is great at explaining the slow movement and the different colors. It's a chemical reaction, not pure energy.
But here's the thing. We have these three really clever, deeply researched theories, and they all hit the exact same brick wall, don't they?
They do. It's the ultimate reality check. You can have a perfect model for plasma, you can demonstrate burning silicon in a lab, but none of those things can explain how the ball gets through a solid wall without leaving a mark.
A hot plasma ball should vaporize the wall.
It should. And a ball of burning silicon dust should leave behind soot, ash, some kind of chemical residue, and scorch marks.
And the fact that it doesn't.
The fact that it doesn't means we have to admit that whatever ball lightning is, it interacts with matter in a way that is completely outside the standard model of physics. We are observing something we simply cannot account for.
Let's pivot from the physics of it to the danger factor.
Yeah.
Because this calm, beautiful, floating light might seem harmless, but it's not.
It is definitely not. It's profoundly unpredictable and potentially very, very dangerous. The source material highlights two very different ways this thing can disappear.
Okay, what's the first most dramatic way?
The first is explosive. In many reports, the energy containment just fails catastrophically, and the ball detonates with incredible force. Witnesses describe it as a small bomb or a grenade going off.
So 1 second it's floating peacefully, the next it's a localized explosion. That's terrifying.
It is. It can cause serious injury, start fires, but then the second way it disappears is the complete opposite.
Which is?
Silent extinction. In these cases, the ball just fades. It shrinks and vanishes quietly, sometimes described as melting into the air. No sound, no residue. It's just over.
They just don't know if you're looking at a light bulb or a bomb.
You really don't.
But if the danger isn't unnerving enough, we have to talk about how it moves, because this adds a whole psychological layer that turns this from a science puzzle into something,
Yeah.
well, something sentient.
This is where it really veers into ghost story territory. Witnesses consistently report that the ball moves as if conscious of its path. It's not just drifting on air currents, it seems to be navigating.
Conscious of its path. That implies it's making decisions. What does it actually do that suggests that?
It maneuvers. The reports say it actively moves around things. Chairs, tables, people. It avoids collisions. It seems to find the path of least resistance.
It doesn't crash into things.
It doesn't crash into things, with one glaring exception, the riddle. When the only path forward is through a solid barrier, and then it just goes right through, no effort at all.
So it avoids a chair, but it will go through a wall. That suggests it can
Yeah.
perceive its environment and then choose how to interact with it.
That's the terrifying implication. How is this localized energy structure reading the room? Is it sensing air pressure, tiny magnetic fields? And if it is, why don't any of our best scientific theories account for that perceptual ability?
It pushes physics into something that feels almost biological. Even if it's not, you're left with this dangerous glowing object that can appear anywhere, vanish violently or silently, and moves like it has a mind of its own.
It's a formal electrical paradox sitting right at the edge of what we know. A structure of energy that seems to defy conservation laws, ignore solid matter, and perceive its environment.
So what does this all mean for you? Well, you now have the essential knowledge about one of the world's greatest electrical riddles.
Mm.
You've got the data on its appearance, the smart but flawed theories, and the disturbing facts about its movement.
The biggest takeaway, really, is that our current understanding of energy has a huge blind spot. Ball lightning proves that under certain conditions, energy can be contained, transported, and navigate solid space in ways we can't replicate or understand.
And that leads us to our provocative final thought, built right from these contradictions. If ball lightning can appear suddenly inside any location, and we don't know how it starts, stops, or gets through a window, we have to ask a different kind of question.
Mm-hmm.
Is the real mystery not about what the ball is made of, but about some undiscovered way for energy to perceive its surroundings?
Huh.
A way that allows it to recognize and simply bypass our definition of what solid even means.
In other words, maybe the riddle isn't the ball itself, but the fact that it seems to understand the room it's floating in?
Something to mull over the next time the lights flicker during a storm. Thanks for diving deep with us.